Hello everyone, how's it going? Long time no see. I've just finished and published the latest update for OSCToolset. I have a few news I will explain a bit at the end of this video of what's going on and what I'm going to be doing for the future of this project. I'm very happy at where it is now. I think I've done something that I'm super excited for how it's looking and working and to get it to as much people as possible. And today I will just show you the different changes that have been going on and what you can expect for the TouchDesigner binding of this plugin. Once you have downloaded files, you will see that inside you have these three folders. One is for the examples. The TD is for the TouchDesigner one, where the examples are there, and the standalone component is here. And then we have the plugin for Unreal, which is under Unreal Engine here. Here you can choose what version of Unreal you want. Right now I will only compile the latest 3 Unreal Engine versions. That's because there is just too many and I don't have space to store them all. So if you need it in the future, you will be able to compile it yourself. The way the examples are set up is that now they are also content plugins. So it's a little bit, well, I would say it's much easier to add into any other project, and then you don't have to create a new one. You can just install it in any project that you have. For example, here I have a simple 5.7 empty project, which is here. And the way we would install OSCToolset and its examples is to create a folder. And again, you can do this for any project that you have. So you just add a plugins folder. Maybe you already have one. And this is where we want to copy the examples. So these, both of them, you will copy. One is the base examples. This just contains some data. And then there is the TouchDesigner examples. The last plugin we want to install is OSCToolset itself. This is the C++ only plugin, and then it's under UE plugin 3.0.1. And because I'm in the latest version for the examples, you will have to copy this one. Once that's done, you can just open the project and everything will be already set up. Depending on how you have your own project set up, you will have a different opening map or whatever. Now the examples live under plugin folders. If you don't see the plugins folder, you have to go to these settings and show it here. So you can see that I have my plugin content showing, and that what I want to do is to go to examples for TD, and here there is the map with all the examples previously and 2 new ones that I will show in a bit. So as you open it, you can see we are already here. And if I start, everything will not work because we don't have the TouchDesigner examples open. So let's just do that in a bit. Once you've opened it, you can put it side by side, or if you have 2 screens, you can set it up the way you want. In Windows, I just like to do this most of the times. And now out of the box, once you start, you will see that the different examples start to populate. So you can see that if you see these balls, it means that it actually worked. And we can also see it in TouchDesigner if this is actually at 1. So if we stop, you will see that there are events for initialize. So a lot of things didn't change. All right, before I show you all the different examples, I'm going to do the tradition of actually changing the size of a sphere. I think it kind of shows the process between the 2 programs and how easily it has become using both of these plugins and components. So let's just do that. What we want to do is to send a value from TouchDesigner. In this case, I usually just use the noise. I'm going to time slice it, and this will be the size of my new sphere. What I'm going to say here, I'm going to say this will become the size, and this will dictate the size of a new blueprint that we can create here. What I'm going to do, I'm going to go to the content of this project, which is completely empty. I'm going to add a new actor, and I'm going to say this can be my sphere. Once I open it, it's an empty actor. So what I'm going to do is to add an actual sphere. This is a static mesh, so that we can see the actor in the world when we drop it. Here you can see it right here. Once I play, this sphere is now static. There is nothing changing its size. This new Unreal Engine plugin, it's basically an iteration over the last version. but I think it improved a lot the process of setting receivers and actually using them. So this is what I'm going to show you how it works in the new way. We want to delete or not, depends on what you're using, but I'm going to delete those two events that I'm not going to need, and no need to save that for now. I'm going to make the Unreal Engine a bit bigger so it's a bit easier to read. And all I want to do, instead of adding actor components, because here you will see that they don't exist anymore, is to add them as structs. And the structs are data containers, and what happens is that they are a lot lighter than a whole actor component, and it makes it a lot easier to manage and create them in bulk. For this simple example, I'm just going to add a receiver. So here you can call the add receiver. And this is called through the OSCT manager, which is very handy. And you have a few methods to actually set this receiver. We can split this struct and do it directly from here. Or we can maybe promote it as a variable and say, you can call it receiver or sphere size or whatever name you think it's according to what it's going to do. I recommend to put some actual naming that makes sense. Once you compile, you will have the access to all the values of this specific struct. And what we want to do is to give it the actual address we set, which is size. By default, the module type will be float, but you have a lot of different types that you can actually receive data from. Let's just say float. And what I want to do is to also get a tick event for this receiver. If I compile and I'm going to start this project, I don't need to save. I maybe open the output log 1 second, which is a bit hidden. I really hate this new system of Unreal. Wait, I'm going to take it like that. That's going to be easier. So once I start the project, it will usually give you a warning, right? Unreal has a lot of logs. There is a specific category for OSCToolset. You can take everything out and maybe go to OSCToolset, and this will just give you messages regarding that specific plugin. You can see that we have a warning. It's saying that we have to implement an interface. That's true. Every actor that's going to expect to receive something now will actually use an interface to get those messages and those values. Before, as I was using these event dispatchers, you could actually just subscribe to that event dispatcher and get it. And now that is replaced by the router. So here you will go to the class settings of the actor that you want to change, and you have to implement a new interface with here, just add it, and we can I called it router. So this is the OSCT router. And once you do that, you will see that there is a new category of interfaces. One is called OSCToolset. And here we have an array of different types that we can receive the data. Because I want to receive the sphere size and I subscribed it as a float type, I basically have to get the float event. Under float and receivers, you will see there's like a few different functions. There are the base function for the float. This would be it. This will be triggering the rate that we are actually sending that value. We also have the float tick. A lot of the different values have that tick, for example, the rotation, and the tick will basically be interpolated to the game time of Unreal. Because I've used the tick, I will show you both of them, and I will just use the tick first. Once you have that function here, it's as easy as grabbing the sphere, for example, and we can set the scale 3D, so for the world. And although the scale is actual vector, we can just use a float to make it uniform. Once I compile and I save this blueprint, if I start, you will see that it added a receiver, and now it actually is not giving me a warning anymore. We are not seeing the sphere change because in TouchDesigner, we didn't do anything with this value, and we actually have to be sending it. And the way it's done is that we have this whole array of senders. You can just make this be active, and you can drag and drop the value type that you're actually wanting to send. In this case, it's a float. So I'm going to drag this and I'm going to send a float. I'm going to stop Unreal for a second, and what I want to do is to connect this noise to the float. So the chop that is expecting is this one, and you can see that here I already have the size connected. By default is appending the ID, and now I just set it to size, so I will take that out and I will start. you can see that it became green. That means the connection was successful. And if I append the ID and I play, you will see that it's red and there is nothing being sent. If you want to use the ID, we just have to get this actual address. This will always be what Unreal will be expecting. And you could go to your sphere, and here you can change the address. In this case would be noise2/size. Again, I don't need to save this map. And now you can see that it actually picked up that address. This is how easy it is to connect a channel from TouchDesigner to Unreal Engine using this system. You can see that it's actually extremely fast, like you have like a few nodes. Yeah, technically with like 2 in TouchDesigner and like 3 in Unreal, you're already getting the values. It's doing a lot of heavy lifting for you in terms of ticking values, giving specific interpolation speeds, which you can, for example, change here. If you want the interpolation speed to be a lot slower, you can add 1, for example, and you will be able to see that it will smooth out a lot more. So it doesn't really have time to grow at the velocity that is changing in TouchDesigner. If we will set this to 10, for example, you will see that it will be a lot faster, but still really smooth. The difference of using the tick and using the base float, you will see that it's at the rate at which we're sending that value. So if I save and I show it, you'll see that it's a bit choppy. This is what you expect usually while receiving OSC, and then you are in charge of actually interpolating all these values. And I think that's where this plugin becomes quite clutch in that sense, because it will just do that for you. Let's say that I have a very poor performance and I'm sending at the rate of 10, you can see that the scale is quite awful unless you're actually wanting that performance. And that is due to the difference between the message rate at which we are actually sending data and at the speed at which we are actually rendering this value, right? In Unreal, this will be right now at 60 FPS. So what you would expect is to smooth it out to that value. And that's where the tick is going to do for us. So we still can send to a very low message rate, but receive it in an interpolated frame rate of Unreal. Great, once you have it set up and it's working, now I will go a bit into the changes, what was added, what kind of changed. To summarize it, Unreal Engine plugin is completely new. It's like there's nothing alike of what it was, but it still functions with the older TouchDesigner component. What changed is the way the data is parsed and filtered and interpolated, which makes it much faster. And there are a few additions into the TouchDesigner component, which I will go through. Starting with the component and the way we send and receive data, one of the important parts will be the settings. So once you go to your project settings, you will now have OSC toolset, which this was true before, but there are a few new things. Previously, there is still a bug in the OSC of Unreal Engine where if you set a local address to 127 something, it doesn't work, right? So I've changed a few things, and previously I created an automatic IP address, IPv4, for both the component of TouchDesigner and Unreal so that it would automatically work. That generated some issues in some cases where people were offline or without a network. So what I've done is to check it off, but this is still an option. So by default, this will be off, and you will be sending and receiving to 000. This is the most important one. It's like a solution that someone found. You just use this address. This will be now the default. That means that in TouchDesigner, the component, you will have to send it to localhost. The 0.0 address is mainly for Unreal. So if your server is set up like this, it means that you will receive it in the machine. Another new addition to the TouchDesigner component are a whole array of new receivers in TouchDesigner. So they are senders in Unreal Engine. What it means is that now you can actually receive different data types in TouchDesigner from Unreal. For example, you can get a vector 2 or a vector 3, rotations, color, you name it. It will be all directly parsed for you. For example, here I have the event. This will be the same, so I can check if the character enters or leaves the perimeter of this box. In this case, for the Boolean, I can check if the character is inside or if it's not, which is quite nice. You can directly do it. In Unreal Engine, these senders are extremely simplified right now. So we can try to look for them here. Let me open the senders, the Boolean, and this is this one. I'm going to make this a little bigger so it's easier to see. And I'm going to make the UI a little bigger as well. You can see now that I removed the actor components, which I will go in a little bit. But to send this active value, in case if it's the character inside or not, you can see it's pretty simple. We add the send Boolean, we add a specific address to it, and we give it a value. There are no need anymore for actor components. It's a lot easier to send and create receivers. As the Unreal Engine plugin changed a lot, I'm going to show you how it actually changed in Unreal and the blueprints in order to receive the data from the examples of TouchDesigner. So I'm going to go one by one, and I will link them in all their videos so that if you are interested, you can actually see how it is done now. I will start with the first example of the audio reactive. You can find it here in the examples of TouchDesigner, the audio reactive. This will be the map. You can just open it. I already had it open. And in TouchDesigner, in the file examples, it will be here. You can see that the TouchDesigner setup didn't change a little bit. Nothing actually changed. But what did change is the implementation of Unreal Engine. What we can do is to open here and see the Niagara spawner. That's what I added. And I'm going to make this a bit bigger so we can see how it actually works now. As you can see, the actor component has been removed. It's no longer there. And the way that we add a new receiver is like this. So we, at begin play, call a function which is called add receiver. You can see the target is the OSCT manager. And we actually give it an address of null audio/kick. This is the same address as we have in TouchDesigner. You can see here the null audio low. So that when I play, you will see that in TouchDesigner it gets triggered on the kick. That's the one we are calling. What you will need to set is what receiver module type we are actually wanting to connect to, which will be an event. Here you can see that you have all the different types. And here you also have the different functions and different things you can set that we were able to do in the actor component previously. I will open now the second one, which was the face tracking. This is like a remember examples. Let's see, we're gonna open this. Maybe you have to enable your video device. I will also open the example in the face track. Not gonna save anything. And here, let's see if I just disable that and I'll play. So you can see now, actually you cannot see me, but you can see kind of if I move, it goes with the face. And again, it didn't change much in terms of the TouchDesigner setup. Actually, I didn't change anything here. But for those that are new, I can just show you that it actually has been sending a rotation of my face. It's actually sending a position of a vector too, and it's sending all the different points, which I can trigger with the space while I'm in the different thing inside here. Let's watch the difference then. When I'm here, I can go to the face, and there is a blueprint. This is where the actual OSC is being parsed. And we're going to see a different method of adding the actor components, which in this case have become structs. So they are containers of data that are very simplified for the only things that we actually need for these OSC receivers. Instead of using an add receiver, you will see that we get an array. There are a few functions to add receivers. You will see that we have an add receiver. This is for a single one. We can use add many receivers, which is what we are using here, which is an array of them. If I open this array, you will see it's like if we just added 3 different actor components in our actor, but instead they became 3 different array elements on the OSCT receiver. What I'm doing here is to match the address with their module types and using the specific settings that we need. For example, the position is a vector 2, the address is face_pos at 0, And then that's what we can add here with just one simple function and one array. Just like we did before in the class settings of this specific blueprint, the BP phase, I've implemented the router. So you will have to implement that anywhere that you want to receive these events. And here we will get this new array of functions that we can now just use. For example, we have a rotation tick, we have a vector tick, and we have a vector2 pack tick. The next example was material control. This was an example to show that you can actually name certain channels the same way you name material parameters, so that you can directly connect it without having to do a lot of renaming and stuff. I'm going to open the project. I'm also not going to save anything. And you can see it's here. And if I open this space, you will see that everything has been connected. And you can see how I set up that project, but basically you can control specific values of the material directly from here. What I'm going to do is to open again this material manager, and we will see how this was set up. I'm going to make this a bit bigger. And you can see that I create a dynamic material instance. I set the material to this static mesh that I created, and I'm using the same method. I'm using an array of receivers, which is in this case quite a lot. And it starts to allow us to actually control the material. If you have the older example, you will see it's a little bit more cumbersome. And this is how simple this became. What happens here is that when we receive a float, we basically get an address, which is previously named the same way we named the parameter name. And that's why this conversion works. That's why when we send a vector parameter or a float, it will directly map into the material. These examples that I'm going to show are new, and they are going to show the new utility for the TouchDesigner component. I think for bigger projects, this will be a lifesaver. And basically, it's called OSCT export. And what it will basically do is to grab all the modules, so all the senders from TouchDesigner, export them in a JSON so that we can import them in Unreal Engine through a file. And that basically means that we can automate the process of adding receivers through a data table. What a mouthful. I'm just going to show it to you. I created two different examples where I'm using this technique, which is quite cool. The first one is the same as I just showed, but instead of having to add all the different receivers through an array, I will be using the data table. So let's just open that example. Let me show you here. This is the IO receivers, and I'll just open it. And it's the same, so it's just going to change the thing. But inside, instead of actually sending the values and adding them, it works through this data table. This data table is connected to a JSON file, which is created by this OSCT export. And you can see here that it basically will set the proper type, the proper address, given of what we have in our setup that we are targeting. The way that works is that we can drop OSCT export anywhere in our project, and we can target what component we want to parse so that we can actually get all the channels. Here in the component, the default will be set to this expression, which means parent, which means to this parent. So everything that is inside in this parent will be treated as something that we want to export. You can basically adjust this to what you want, and here we can give it a name. You will also save it to a specific location, which is wherever you are opening this project at. And once you export, we will be able to open it. If I now go to my project, which I just saved in the desktop, I open the TouchDesigner file, you will see that we have this new JSON. And here I'm gonna maybe rename it a little different so I can show you what I mean. I'm gonna name this as an example, and I'm gonna re-export it. You will see now that I have these two JSONs, and I'm gonna open the latest one that we just exported. And it will open maybe in the text editor that you are using or whatever you are actually gonna use. And you can see that it will create for you a data structure of all the receivers that Unreal would be expecting of this given profile, of this given example. The way that I've been using this is that in your content drawer, you can basically drag and drop this JSON file. So what I'm going to do is to drag this new JSON, and it will prompt you with what data table structure you want actually to use. Here you will choose a data table row as OSCT, and here will be the receiver row. Once you apply, it will appear here, and now this is your data table with all the different things that you actually have. The power of this methodology and this process is that it's actually binded to this JSON file that is in your machine. And for example, let's say that you are prototyping something and you are just interested to send the floats right now, and you are not interested to send these colors. This export offers you different methods to filter what modules you want to export. For example, here, the module type, instead of setting it to all, I'm just going to say I want to send the float. And here you will see that there are like 2 different modules that it's going to be sending. Actually, this should be just one. I think there is an issue with this export because there is this float I was using to test. This you can delete, and when you go up, you will see that it's actually just one. If I go to color, you will see it's only the 3 ones that are here. For now, I will just show with the float. So once you just have the one and you export, you will see that nothing happens in Unreal, but we can re-import this file, and now you see that there are only 4 channels that have been set. As you can see, they are only floats, so it kind of shows you how powerful this can be, because if I decide that I want to send more things, I can just export it, re-import the file, and now everything has been set up for you. Once that's like that, what you have to do is to actually add these receivers from this data table, and that's extremely simple. Once you open this blueprint and you see how it works, is that instead of using the add many receivers, so here, remember you had the add many receivers, instead of using this function, we are using the add receivers from data table. And what you have to do is to target what data table you are actually populating it from. Once you do that, it's just using it as we had. So it's extremely fast. And you can see that they are all connected and that they still work. The latest example that I can show you today is the widgets one. If you open it, you will see this is the example in TouchDesigner. And again, in Unreal 05 widgets, just don't save anything for now. And here, when you enter, you will see that I kind of created a very bad DVD example that doesn't even bounce. I'm sorry. The reason I've set up this example is because we are actually free from actor components, and that means that we can get these OSC functions in any object that allows blueprints and interfaces, which are quite a lot in Unreal. And widgets were one of those things that before you had to cast to them and maybe send their values, and this new Unreal Engine plugin basically made it extremely easy to set up. This is this widget which has this DVD, and this actual text is added as a variable, so we can change their color or the position or etc. And now instead of having a blueprint, we can directly basically add the receivers in the widget. Just as I showed before, I'm using this export to get all these values, and I'm generating a data table. And this data table will allow me to get all these different values. For example, here I have the vector2 tick, which is going to set the translation. That's what actually sets the position of the DVD. I forgot to mention, but you have to enter with the character to actually see the widget. And this is this position, is this noise. So if I'm going to make it a bit smaller, it will stop, but it will still grow in size. And this gives it this position. I'll just leave it small for now. You can see that in this position, I'm actually multiplying by a specific size. And this is one of the new additions for the TouchDesigner component, which is this get vector, is a new receiver in TouchDesigner. And what I'm doing in this widget in begin play, when the actual widget is constructed, is to send the vector to, which in this case I'm setting as the size, right? I get the game port view size, and then I can get the actual window size of this viewport. You can see it's almost a square. It's because I'm recording right now in this dual setup. But that means that you can dynamically get viewport sizes extremely easily. And the senders don't require any setup. You just send the value that you want to send, and in TouchDesigner, you just get it. In this case, viewport/size, the address will be viewport, and the name will be the size, which is split in the two components of a vector too. One last thing that I want to add is that now every single module has a new set of options in its debug. And this debug, it's basically used for the export. That means that we can specifically set what is the behavior of the export. For example, let's say that the color is enabling the tick and we have a specific interpolation speed. If I would disable it and re-export and actually get the value, they would be changing the data table that represents that widget. But you can also change it directly from the data table. So for example, if I go to the color, I can go to the tick and say, hey, don't tick the color because it's way too intense for my performance. And if I now gonna look at how it works, so if I will re-enter, the color will just not change. That's because in my widget, I'm using the color tick function. And what I maybe want to use if I am not using a tick is the base color function. In here, we'll go to receivers. Let's go to the color, and I will just get the color. When you get a function without the tick name, basically you are getting the source rate at which you are receiving the OSC. In this case, I will just use the color, and it will become a little bit more choppy if depending on the rate you are actually sending the color. Well, thank you for watching. I hope it was a bit shorter than usual. Probably not. Anyway, the main news is that I'm going to be open sourcing the Unreal Engine plugin. That is not including the TouchDesigner binding. Long story short is that 1 year ago or so, I did apply for an Epic Mega Grant, which I did not get. I applied so that I could open source the whole project so everyone could use it in different projects. I thought, it's actually helping quite a bit of people. So I just wanted to make that bigger list and that more people can actually use it, because I think that a lot of the practices that I'm doing in terms of setting up servers and senders is quite helping out a lot of people that maybe don't have that technical knowledge. I'm going to link to a text which I will write so I can explain a bit more in detail of how this will work. But basically, this product will be split in two. There will be the plugin for Unreal Engine will become open source, and the TouchDesigner binding, which will stay as a paid product. This will allow me to keep on developing and maintaining this tool because, it does take time and it's not extremely easy over time. And that it will help me to do those things. I can open source it for more people and I can still be able to keep a revenue on it. If you have purchased any previous versions, you will be able to claim them because this update will be free for you. You will have to sign up to my new website. There will be a link. You can either claim it in the base URL of the tool for OSCToolset-TouchDesigner, or you can go to your profile. You can choose. You will see here that you have one purchase to claim. And once you do, you will be able to just download it. The same goes for the base page. You can also download it here. If you notice, there is another price. This is for studios. If you are actually going to make quite a bit of an income and you're using this tool, it will be great if you can actually purchase the studio license. This allows me to maintain the product. There is the same files, but it's going to be a lot more helpful for the future of maintenance for this project. From now on, the goal is to create maybe more bindings and focus more on examples so that people can actually implement it or just use it for their projects. I'm working in an Ableton binding, which I think is going to be very cool. It's going to be a bit quite similar, basically. The idea is that through Ableton, just like you can do now in TouchDesigner, you can just drop a few Max devices and directly send notes and different things. But I don't have enough work to actually show. Another reason to open source just the Unreal Engine plugin is because Unreal releases so many versions that it's just difficult to keep track and just keep the amount of different systems that can work. And I don't have enough machines to actually do it. That way, if you are using Linux or you are using macOS, you can actually compile that version for yourself, and you will be able to set that up. I'm still working on the documentation and a little bit the repository for the open source version. I'm going to make a specific video just for the OSC toolset, a bit more in detail, and then I will release it. That will come much sooner. I think I can be done in a couple of weeks. And this month I will just focus on doing examples and just working a bit on it myself, which I'm quite excited for. Great. Now, yes, for sure. Okay, bye. See you next time. Maybe it doesn't take so long. Okay, bye.